to Chemistry Solutions. This is a GCSE revision video and it's taken from section 4.3 of the AQA syllabus on quantitative chemistry, and it's specifically about reacting masses in chemical equations. It's relevant for all exam boards. Please feel free to pause the video as often as you like and as often as you need to. So, reacting masses. The masses of reactants and products can be worked out from balanced symbol equations. Equations can be interpreted in terms of numbers of moles. Let's look at this example here. A simple balanced equation, Mg plus 2HCl goes to MgCl2 plus H2. The equation shows that 1 mole of magnesium reacts with 2 moles hydrochloric acid to produce 1 mole of magnesium chloride and 1 mole of hydrogen gas. A typical question will be, if you use 10 grams of magnesium, how many grams of hydrogen do you get, or how many grams of magnesium chloride will be made? And these questions rely on everything that you've learnt so far. More often than not, equations are balanced, but you may have to balance an equation, conservation of mass, and the Mr. Moles with a mass on his head triangle. The general method for reacting mass questions is step 1. Work out the number of moles of the substance for which the mass has been given, using number of moles equals mass divided by Mr. Step 2. Use the ratios of moles in the balanced equation to work out the moles of the other unknown substance. Step 3. Work out the mass of the second substance using the Mr. Moles triangle with mass equals moles times Mr. So let's look at a worked example. The one I quoted earlier. Magnesium plus hydrochloric acid gives magnesium chloride and hydrogen. Mg plus 2HCl goes to MgCl2 plus H2. And here's the question. What mass of hydrogen would be produced from reacting 2.4 grams magnesium with excess hydrochloric acid? So you will see there are 4 substances in this equation. We're only interested in 2, the magnesium and the hydrogen. So let's look at step 1. Work out the number of moles of the substance for which the mass has been given, magnesium, using the number of moles equals the mass divided by the Mr. So the moles of magnesium is 2.4, because that's the mass from the question, divided by 24, because that's the AR for magnesium, and that equals 0.1 mole. Step 2. Use the ratios of moles in the balanced equation to work out the moles of the other substance. So we refer back to the equation. We're only interested in magnesium and hydrogen. If we look at the numbers in front, the number in front of magnesium is a 1, and in front of hydrogen is a 1, so it's a 1-to-1 ratio. So for every 1 mole of magnesium, there's 1 mole of hydrogen. So we can say that if there's 0.1 moles of magnesium, as in our first part of step 1, then there should be 0.1 moles of hydrogen. Step 3 then means work out the mass of the second substance, hydrogen, using the mass equals moles times Mr. So we've just learnt that the mass is the 0.1, which is the moles of hydrogen, times the MR for hydrogen, which is 2. As you can see here, we've worked that out in the bottom left-hand corner. So the mass of hydrogen produced is 0.1 times 2, which is 0.2 grams. Now, this method works very well for those of you who are good and confident at working with numbers. However, I've made a table method which can be used and works every time if you're not so confident with the maths. It's a bit long-winded and it needs practice, but it works every time. So we'll use the same worked example. There it is. You don't need to read it out. Step 1, write down the 2 substances from the equation that are in the question, and we call these the known and the unknown. In this case, the known is the magnesium, the unknown is the hydrogen. And now you'll see why we call this the table method. So for step 2, down the left-hand side, in that order, you write the mass, mister, mole and ratio. Step 3, enter the mass and the mister of the known substance, whichever side of the equation it's on. If you wish, you can put a line down the middle just to separate the two halves. That's up to you. The mass from the question is 2.4 grams, and we were given the MR of magnesium, which is 24. Step 4, same as before, use the Mr. Moles triangle to calculate the number of moles of magnesium, which is 2.4 divided by 24. And you can see why we've put them in that order, because it's simply a dividing sum from 2.4 divided by 24 at the top there. So 2.4 divided by 24, 0.1. Step 5, enter the ratio of magnesium molecules to hydrogen molecules from the equation which is above. And we can see the ratio is 1 to 1. Step 6, enter the moles of hydrogen from the ratio. In other words, 0.1 moles will give 0.1 because it's a 1 to 1 ratio. Step 7, enter the MR of the unknown, in this case hydrogen, which is 2, as we've already worked out previously. The final step then is to use Mr. Mole's triangle to calculate the mass of the unknown substance hydrogen. By covering up the mass, it's the moles times the Mr. So if we go back to our table, we can see we've got 0.1 from the moles, 2 from the MR, 0.1 times 2 equals 0.2 grams. So this is the table method. It has to be learnt and you have to follow it methodically, but as I said, it works every time. You start with the mass of the known and then you work down to work out the moles, and then you insert ratio. Go across then to the right to put the ratio into the numbers of moles of the unknown, and finally you work back up the second column to work out the mass of the unknown. And you can do this either way. You can start on the left or the right, and we'll show some examples where we start on the right hand side as well. So it's up to you. Do you use the simple steps 1 to 3 or steps 1 to 7? The table method. The choice is yours, but as I say, have a go at a few examples and we'll do some more here on this video. Let's look at an example using the 3-step method. Calculate the mass of oxygen needed to react with 100 grams of calcium to form calcium oxide. Relative atomic masses are calcium 40, oxygen 16. The equation is here in balance. 2Ca plus O2 goes to 2CaO. Step 1, we're going to work out the moles of the known, and the known is the 100 grams of calcium. So use the formula triangle, Mr. Moles with a mass on his head, cover up the moles, and it's mass divided by the Mr. The Mr for calcium in the question is 40, so 100 divided by 40, 2.5. So that's the moles of calcium. So step 2, we need the ratios for the moles to work out the moles of the oxygen. So the ratios are in the equation, and if you look at the top there, the ratio of calcium to oxygen, 2 to 1. So for every 2 moles of calcium, there's 1 mole of oxygen. Right, so that moves us on to the next bit now, which is step 3, the moles of the unknown of oxygen, which we convert into the mass of oxygen. So the ratio is 2 to 1. So if you've got 2.5 moles of calcium, you must have half that for the moles of oxygen. So 2.5 times 0.5, 1.25 moles of oxygen. So now we use Mr. Mole's triangle. So the MR for oxygen is 2 times 16, which is 32. So the mass of oxygen will be 1.25 times 32, which comes to 40 grams of oxygen. So we'll try the same question, but this time we'll use the table method, and then you can decide which is your preferred method. So here's the equation, 2Ca plus O2 goes to 2CaO. Remind you of the question. Calculate the mass of oxygen needed to react with 100 grams of calcium to form calcium oxide. And you've got the ARs for calcium and oxygen there. So as before, we just consider the two elements this time from the question, which is the calcium and the oxygen. The calcium is the one that we know the mass of, and the oxygen is the one we're going to try and find. So you put the two at the top, then down the side you put the mass Mr. mole ratio, and there's a reason for that order. And sub in the numbers from the question. 100 grams of calcium, the MR for calcium is 40. Do not multiply it by 2, it's the pure MR. Then using the Mr. Mole's triangle, you're going to work out the moles of calcium, and that's 100 divided by 40, hence the order. That comes to 2.5. Then let's look at the ratios. The ratios, remember, are the numbers of moles, the numbers in front. 2 in front of calcium, 1 in front of oxygen, 2 to 1. So for every 2 moles of calcium, there is 1 mole of oxygen needed. In the question, we've just worked out that there are 2.5 moles of calcium, so there must be half that number, 2 to 1, of moles of oxygen, which is 2.5 divided by 2, which equals 1.25. We can put in the MR for oxygen. That's 32 because it's an O2 molecule, remember? And now all we need to do is Mr. Moles with the mass on his head again. This time we're working out the mass, so it's moles times Mr. 1.25 times 32, 40 grams. Now, my preferred method is the table method, so I'm going to use that from now on. It's up to you, you have the choice. So let's try a slightly more challenging one now. What mass of propane could burn in 48 grams of oxygen? So the oxygen is our known, isn't it? That's one we know because we've got 48 grams of oxygen. And the propane, that's the unknown. That's the one we're trying to find the mass of. So we set up our table with the mass Mr. Mole ratio down the left-hand side and the known and the unknown at the top. And start to fill in the details, sub in from the question. So the first one that goes in is the 48 grams of oxygen. The MR of oxygen, well, that's 2 times 16 equals 32, because remember it's O2. For the moles of oxygen, we use our formula triangle, cover up the moles, and it's the mass divided by the Mr. 48 divided by 32, 1.5 moles of oxygen. So if we look at the top, we can find the ratio. The ratio is 5 of oxygen to 1 of propane. So we put that in 5 to 1 ratio, and then we work back up the other column. For every 5 molecules of oxygen, there are 1 of propane. So if there are 1.5 moles, there must be 1.5 divided by 5 moles of propane because of the 5 to 1 ratio. Now the MR of propane, that's easy. We've got 3 carbons and 8 hydrogens. So that's 3 times 12 plus 8 times 1, 44. Once again, using the formula triangle, the mass is the moles times the Mr. 0.3 times 44, 13.2 grams of propane. Question done. So let's look at an exam question. Magnesium reduces silicon dioxide. The equation for the reaction is 2Mg plus SiO2 goes to Si plus 2MgO. Give one reason why the products are difficult to separate if magnesium is used to reduce silicon dioxide. Pause the video, have a go, restart, see where you get. This is a question examining your knowledge of state symbols. If you look at the equation, you can see that the two products, silicon and magnesium oxide, are both solids. So if you get a mixture of two solids, they would be extremely difficult to separate. So to claim 1 mark, both products are solids. Now the second question, this is the actual reacting masses one. Calculate the minimum mass in grams of magnesium needed to completely reduce 1.2 kilograms of silicon dioxide. And you've got the relative atomic masses there. So our silicon dioxide, we've got 1.2 kilograms, so that's our known. So the magnesium is the unknown. Again, pause the video, have a go, whichever method you use, see what you come up with. I will use the table method and I'll pick the two chemicals, the 2Mg plus SiO2, and that's the headings for my table. Mass Mr. Mole ratio down the left hand side, let's sub in. We've got 1.2 kilograms of silicon dioxide. Now we can convert this to grams now, or we can convert it at the end. It doesn't matter. The MR for silicon dioxide is 28 plus 2 16s, makes 60. Moles is mass divided by MR, which is 1.2 divided by 60, 0.02. The ratio from the equation is 2Mg to 1 SiO2. So if we have 0.02 moles of silicon dioxide, we'll have double that, 0.04 of magnesium. MR for magnesium, 24. So the mass of magnesium, 0.04 times 24. That gives us 0.96 kilograms. Convert now to grams, times by 1,000, 960 grams. So there's 1 mark for the MR of silicon dioxide, 1 mark each for the moles of silicon dioxide and magnesium, 1 mark for converting somewhere from kilograms to grams, and 1 mark for the final answer, 960. Next question. Titanium is extracted from titanium chloride as shown. Calculate the mass of sodium needed to react with 126 grams titanium chloride. And the ARs are there. The equation, TiCl4 plus 4Na goes to Ti plus 4NaCl. So we take our known and unknown, which is the titanium chloride, TiCl4, and the 4Na, put our mass Mr. moles down the left-hand side. So we sub in and follow the method, 126 grams of titanium chloride. The MR is 48 plus 4 chlorines, that's 190. The moles, 126 divided by 190, 0.6632. From the equation, the ratio of titanium chloride to sodium is 1 to 4. So if there are 0.6632 moles of titanium chloride, there'll be 4 times that moles of sodium. And back up, the MR for sodium is 23. So 2.65 multiplied by 23, 60.95. And if we round that up to 61, that's the number of grams of titanium chloride, sodium required to reduce 126 grams titanium chloride. So the final question, this is definitely an extension and it's definitely a grade 9 question. But again, if you follow the table method with a slight tweak, you should be okay. 6.15 grams hydrated magnesium sulfate decomposed to form 3 grams of anhydrous magnesium sulfate on heating. Calculate the formula mass of the hydrated magnesium sulfate and the value of X, and is X. MgSO4.XH2O gives MgSO4 plus XH2O, so it's a decomposition. There's a lot of information with this equation. The MgSO4, that's on the left, that's hydrated. On the right, the MgSO4 on its own, that's anhydrous. From the question, we've got 6.15 grams of the hydrated. On the right-hand side, we're given 3 grams of the anhydrous magnesium sulfate. So what's on the left must add up to what's on the right. So we need another 3.15 to make that up to 6.15. So the mass of the XH2O is 3.15 grams, and we'll come to this later. Now we can use our table method once again. We've got our MgSO4 at the top with our XH2O, down the left hand side the mass Mr. moles ratio. So we sub in our 3 grams of MgSO4. The MR for MgSO4 is 24 magnesium, 32 sulfur plus 4 16s, 4 oxygens. That gives 120. To get the moles, mass divided by Mr, 3 divided by 120, 0.025. Now we're working out the ratio, but we have got a mass of XH2O. So this is where it's slightly different. We put the mass in for the XH2O as follows. 6.15 take away 3 gives us 3.15 grams H2O. The H2O MR is 18, so to get the number of moles of XH2O is 3.15 divided by 18 gives 0.175. So now we have a ratio of moles of the hydrated to the anhydrous, 0.025 moles of the hydrated to 0.175, but our ratios must be whole numbers. To get a ratio into a whole number, we divide both ratios by the smallest number, in this case 0.025. So if you evaluate this through, 0.025 divided by 0.025 is 1, and 0.175 divided by 0.025 is 7. So the ratio is 1 to 7. So X must be 7. Now we can sub X into the formula for the hydrated magnesium sulfate. So we've got MgSO4 7H2O. So the second part of the question is the formula mass. So the MR of the MgSO4 7H2O is 120, which we've already worked out previously, plus 7 lots of water, 7 18s. Crunch that in your calculator and you get 246. Thanks for watching. I hope you enjoyed it. I've got more videos like this for revision. We've also got exam walkthroughs, chemistry walkthroughs. If you click on my site, you'll be able to get those. And we'll see you next time.